Hello, my name is Michael Holmes, and I'll be giving this presentation on cloud databases and linked data. We'll first discuss cloud databases and basically just what is a cloud database. It's just a database run on a cloud computing platform. It's intended to be a convenient way for online data management using different distributed servers. Can be SQL or NoSQL. There are two primary deployment models: virtual and database as a service. In virtual, you try to or you'll have a machine, an image, and a user can either create a machine image, a machine image with a database already on it, uploaded to the cloud, or they can or they can buy it where the database is already within the machine image. An example is Oracle's DB on a database on the Amazon EC2. For database as a service, it's basically where the cloud provider will host and maintain the database within the cloud, and the user will basically pay for their usage. And these examples are the Amazon Web Services database, different databases, the NoSQL, their NoSQL simple database, or their SQL based relational database. And there's a third way that can be done where the cloud providers will manage databases provided by the user, and these include the Rackspace MySQL interface. some of the advantages of cloud databases is that they're often cheaper as for businesses and users because they don't require big expensive servers to be purchased, and they can simplify different IT costs. They can be more easily accessed anywhere because they're online. So as long as you have an internet connection, you can access the database. It's a broadband internet connection, and it's also an easy and convenient way to share the information, and it's reliable. It can be more reliable because if a server goes down, the cloud provider can often switch it to a different server, and often cloud providers will offer reliability guarantees, and also it can be more scalable. A cloud database can be more scalable, can get more space as your database grows, or if it shrinks, you can take less space. And this can be, some providers will automate this, others provide an API to do this. The downside to a cloud database is that the biggest is security and privacy. They're more vulnerable than a regular server database, and they're not as private. They're more likely for a data breach or other security risk. And there's also a question of who's responsible when this does happen. Is it the provider, or is it the user and the owner of the database? It also does require an internet connection, typically a broadband interconnection. If you don't have one, you probably won't be able to access the database. There can be there's also some downtime for maintenance, and sometimes the server can just be overwhelmed from a lot of people trying to access the database. Also, you lose control of some of those resources. While you've saved money, you also no longer own the servers. You no longer own some of the other things associated with that. There's some questions of data ownership. Does the cloud provider have access to some of that data, or even partial ownership of that data? And also, the technology is still yet still yet unproven, and there's some many providers will often several providers go out of business. It's not in the you can off which can cause many problems, and also it's not very easy to integrate or switch to a different provider at this time. Now we'll begin to discuss linked data, and more specifically linked open data. And just what is linked data? Well, it's basically just a web of data. It's using the web to create links between data from different sources. It's publishing structured data so that it can be interlinked and be more useful and meaningful. It's a shift from human-readable HTML to machine-readable document. It does this by using some of the current tools to basically transfer of HTML and RDFA to make it where instead of producing documents that humans can read, we're making it where it's to make it where computers and machines can read it, so that you can link all the data together and provide more powerful queries. And linked data is also a key component of the semantic web. And what are some of in 2006, Tim Berners-Lee proposed 4 what he called rules, or really behaviors, in a memo to the W3C, and these are: one is to use uniform resource identifiers for names of things, and number 2, to use HTTP URI so that people can look those things up, and 3, to when someone looks up a URI, provide useful information using the standards of RDF and Sparkle. And we'll see later that there's some controversy over particularly this rule, this part of that rule, and really all these rules and behaviors. And finally, to include links to other URIs so that more information and data can be discovered. And in a 2009 talk to Tim Berners-Lee kind of clarified this and basically said, or simplified it and said, everything's got a name that starts with HTTP, and we look up those things, names, events, dates, people, whatever, and we look up those things and we find these things, and then we see there different things about them. We can find their data, and instead of just getting the name of the person or their age or a height or weight, we can see their relationships. Who else is involved with those people or events or things? And those things will have names that start with HTTP. And there's also been a star rating system kind of proposed for linked open data. And the first star is to really just get 1 star. You get a star if your data is just available on the web in any format. It could be PDF, could be just an image of it, but with an open license. It must have an open license. To get 2 stars, that data must be available in some machine readable format. And that could be often cited as Excel data. Could be another type of data, but it's got to be machine readable to get 2 stars. For 3 stars, it's got to be still machine readable, but it must be in a non-proprietary format. Instead of Excel data, CSV data. To get 4 stars, and this one is still a bit of this is the controversial one. It's to use open standards of RDF and Sparkle or something so that others can direct their data to your data. And finally, to get 5 stars, you must link your data to other data to provide further context of your data. And it should be pointed out that really only the 5th step is truly linked. Only the 5-star one is truly linked open data. The rest are mainly just open data, but not really linked. And we'll see, especially to the third one, and then to make the leap to the fifth one, you have to have that already. It does technically require to get that 4-star, you have to have those standards, which are quite controversial. We'll see later. And here's an image of some of the many of the linked data sets available in the world. As of August 2014, is a linked open data cloud, which is the last update. It contains 570 different data sets. Two of the main ones are DBpedia, which is basically contains more than 1 billion different data points compiled from Wikipedia. And then also GeoNames, which contains a lot of different data about different geographical places. And then FOAF, which contains is also another one, large one, which contains information about people and their relationships among people. And to be accepted into this, the data has to be linked, while some of the data must be open, not all of the data completely within some of these data sets will be open and available, but may not necessarily be open and available. There are some downsides to linked data. First it's just not real clear exactly what is linked data. First, there's no real clear standard that's ever been adopted. Those rules and all were just in a memo by thoughts by Tim Berners-Lee to the W3C. There's never been anything formally adopted. And so it's not real clear exactly what it is, and the concept is still a little tricky as well. It's like, what is linked data really, and does it require RDF or not? Some say it shouldn't. Others insist that it should, but others want JSON, or to be able to use JSON. Anyway, in fact, some have said they will not make their data sets linked and open unless JSON is allowed. And Tim Berners-Lee has come out later and said that it doesn't really, whether it's linked or not doesn't even matter, as long as the data is out there and open, that open data is more important than linked. And also, publishing the data is kind of not exactly easy. Formatting's hard. It's just kind of like, how do you come up with a HTTP name for everything in your thing? For everything, all the different characteristics and relationships and everything. And what if there's a blank node or an empty literal or something? And also, it's not very easy to actually access the data. It's in RDF often, and you have to know RDF, and it's just kind of, linked data kind of gets away from some of the principles of the human web, and that it forces kind of some of the complex technologies and of the web architecture to be used, where it kind of gets away from some of the web principles of primarily and especially the simplicity. And thank you for watching this presentation on cloud databases and linked data sets. And here are some of the references from this, and I thank you for watching.